I'll hit record. I wanted to start to look at the physics engine inside Max today. And we'll start, I'm going to try to not go too fast with it because it's a lot actually. Because I imagine many of us don't really understand basic terms of a physics engine anyway, or what it could do, or what that means. So what we'll do is construct a world that is a rectangular box, and we will have a ball bounce around that rectangular box, and then we will tie a light to basically be that ball. So the ball will have a light associated with it and will bounce around the room. In the process of doing that, we'll have to run into a few interesting things. One of those is being filter classes and filters. So because there's a physics world and only certain things go in it, you can make it so that things in that world don't collide with each other, or they don't report those collisions, right? So that's what a filter is saying what do I interact with and what do I not care about. So you can make an object. For us, it'll be the thing that picks, like you're able to use your mouse to pick a ball and throw it around or something. You may not want to associate that picker with certain things that would not allow you to do what you need to do. So that's the short of the long. Let me save this one and we'll just start fresh. I will share a screen. Okay. Lucky for us, built into this jit.world, which are many things, so we remember that there is a render space built into this jit.world. There's a window built into it. There's actually a jit.gl.node built into it. And it turns out that there's a whole physics engine associated with it as well. So I'm going to call this the draw space. And here I'm going to say at phys world name physics. So you don't have to name the physics world name. It'll just find it. But I like to do it just for clarity here to make sure we know what's going where. All right, and so just by doing that, actually just by creating the world, we've actually created the physics engine. And there's a certain way to send to the physics engine messages. So let's look here at the reference, and it says send phys, right? So notice these different send things. One says send node. So you remember how I said that the world already has a node associated with it. Send physics, it has a physics engine. Send render, it has a render object in it. Send window. So you can actually send messages to the internal parts of this world. Because remember, this world is a convenience object, sort of. It just contains all of these different things that we could build on our own, but it's just nice to have them all in the same place. So I'm going to drag out this send phys thing, and if I want to send a message to it, I can. Let me do it this way. I will do that instead. And so then we notice that if I say send phys, it says jit.phys.world, I think. Right, so just out of curiosity, we could look at jit.phys.world and then see what all sort of messages we can send to it, because we can send to it with this send phys message. So it's got all of this different stuff, right? Gravity, world box, right? So we can turn the world box on or off. What is a world box? So a world box is a box that could hold physical objects and kind of contain them within a certain part of the world. So it's a box that objects that are in the physics object and are susceptible to gravity. They won't just fall straight off of your screen. They'll be contained within this world. Eventually we'll turn this off, but for now we won't. And we've also got this world box scale. So how big is that box that holds all the stuff? And right now we see that it is 5 by 5 by 5. We can think of that as meters is the best way to think of that. So right now we have a box in this world that we can't see yet. That is 5 by 5 by 5. 5 meters by 5 meters by 5 meters. How do we see such a world? So there's an object. See if I can remember what the name of it is. Phys.draw, I think. Oh, I can't remember. GL PhysDraw. That makes sense. So drawing. So notice the collision of these two things here. We're going to draw a representation of the box in the render space. So here we would say put this on the draw space. And let's get the help here. Enable is an important message to it. So let's go here to the Atruis. Enable. Okay, so it's there. We can't see it. You know, why can't we see it? I believe it's probably because we're too close to it. We're inside it. So let's do jit.gl.camera, draw space. And now we have a camera in the world. And we can position ourselves back toward us on the z-axis. So we'll go back this way. And there we see, oh, there's the box, right? So about 25 meters back, I'm able to see the 5 by 5 by 5. So remember that this is just drawing something that has physics to it. All right, so those are pretty important little things there to know that there is a world box associated with the physics. You can turn it on or turn it off, right? So even though I've turned the world box off, it's still drawn in the GL world, but objects would just fall through it that were physical bodies. And I've enabled the drawing of this physical space, right? So there are sort of invisible things in the physical space, and then we can tie visible things to them. So it's important, what I'm trying to beat dead here with the horse is that it's important to draw a distinction between what is drawn and what is a physical thing.
So Dr. Thompson, this, you wouldn't really use this for aesthetic reasons. This is like utilitarian to just keep track of it, right? Or is this like a artistic tool?
Well, I guess it could be. But generally, no. I would not use the drawing of this physics space as something. It's more utilitarian. However, it does kind of look neat, and so you could use it. But that's not the purpose of it, right? The purpose of it is not to look really good. It's to represent what's there. All right. So now that we've got this physical space kind of up and running, it would be really nice to just put something in it. So that is where we have jit.phys.body. So this is what's called a rigid body. And a rigid body is something that can have mass. It can have a shape. It can have friction and bounciness and all those things, and it can collide with other things in a way that looks natural, right? So it can bounce off other objects or bounce off walls. It can be subject to the forces of gravity or other forces like wind that you put into the world. It is a physical body. So here I think I tell it to be on the physics space here. And let's look at a couple attributes. So let's say that the shape of this is going to be a sphere, although I could make it a cube or a cone or a capsule, or actually have my own sort of shape for the physical body. And the shape for the physical body does matter because that determines how it kind of moves in the space, obviously. So let's just say at shape sphere, and we'll leave it at that. And boom, there it is, and it fell down into our world box.
I have a quick question. What part of the computer is computing this? Is it the graphic processor or the CPU?
This would be the CPU. So it's all CPU based physics engine. All right, so there the thing is, right? If I turned off the drawing, we still wouldn't see it. So remember, that's not a drawn object necessarily, it's just a physical object. If I turned off the world box, then it would, well, I thought it would fall just straight through the floor, but I guess it didn't. I guess that was nice. And, right, so one more little convenience thing here is the picker. And we'll make sure it's enabled. So notice that it's got this enable thing here, and it's also got this dynamics thing. Both of those need to be checked for this to work, and they are by default. So now I'm able to use my mouse to grab this sphere, and notice that it's kind of constrained to the mouse on the edge of the surface, and there's some degrees of freedom. It acts kind of like it would in a physical space, and I can throw the ball, you know, do all this stuff. So the picker becomes kind of nice. It will tell you which object you have picked. You can do that either on the click, or you can actually have it tell you on the hover, you know, I'm over this object. So that might be useful to you. We won't use that today. All right, so that's this thing here. Now what's typical though is that I want this to not look like, to not have to rely on this drawing, right? I want to have some sort of object like we're used to that's bound to this physics body. And that's simple to do. So jit.gl.gridshape, let's say, although it could be almost anything. And we're drawing this grid shape on the draw space. And we'll make it the shape of a sphere. And then to bind it to this physical body, all you have to do is hook the physical body to the grid shape. And now they're one and the same. So what that means is that this physics body is outputting all sorts of information now to this grid shape. It doesn't come out this outlet though. It only comes, it goes directly. So you won't be able to see that. But you see it says position or quat values. Quats are quaternions. Basically a way to navigate 3D space. Just because I don't like the way that that grid shape looks just without any lighting or anything, I'll just throw a material on it so that it looks like something. All right, so there we go. And it's kind of colliding, but it's not really doing any bouncing or anything. You know, it just kind of falls down and rolls. So let's make it so that this box, this world box, gets replaced by a real box in our space. So I'm going to build a floor and 2 walls to start with. So in this case, I'm going to need more physical bodies. And in the shape of a cube, and I'm going to build the floor first. So I want it to be not very tall, because floors, you know, tend to be less tall than they are wide and deep. So I'll make a cube, and I'll make the scale of it to be 5 wide, because that's how big our world box is right now, and 0.1 tall, so only 0.1 meters tall, and then 5 meters deep. And I'm going to position this at 0 on the X, -5 on the Y, so place it down on the floor, and then position it 0 on the Z. And now we have a floor on the bottom, right? So now if I do this, it can have different characteristics. And I could In the end, I could turn this world box off somehow, although I'm not having a lot of luck with that. And deal with it. All right, so one of the things I want to have happen is I would like for this to bounce. So to do that, what I need to do is I need to tell this body, well, the first thing I need to do actually is I need to give this floor 0 mass. Why do I give the floor 0 mass? I give the floor 0 mass because I don't actually want my floor to really act like a physical object in that it might fall to the ground, you know, or anything, or fall to the center of the earth and then beyond. So anytime you don't want something to really behave like a rigid body in that it won't react to gravity, you give it a mass of 0. That's, for me, has been just building walls and floors. Some other things we can deal with here are, let's do it with the body here. I'm going to change something called the restitution of this. So the restitution basically means bounciness. Think of it that way. And it's a number between 0 and 1. And if I make this number pretty high, like that high, then in theory, oh, I've got to change something here too. Ooh. Maybe this also? There we go. So now it has some bounciness to it. I'm just going to put this to 1. And so now we have this bouncing ball. I'm going to place this at 1 too, which would kind of mean this ball is just going to bounce without much resistance to stopping bouncing. So it'll just kind of bounce like that. There is some damping right now though, so there's some things that are making it so that it stops bouncing. So let's take a look at those. Restitution is set to 1. I will just go ahead and hard code that in here. So restitution, our vocabulary word for the day, is bounciness. Okay, so something else we could change would be the damping. So it's got damping on the X and the Y here. And I'm just going to set those to 0 for now and see if that changes our the bounciness of this ball. And not so much. And there's also this idea of friction. So friction, if this ball had some spin on it, then it would react by kind of acting like a ball would with friction. If I have no friction, right, then it's probably not going to react to the spin quite as much. And it's also going to bounce for a lot longer because there's no friction on the floor. So the goal here for right now is just to try to make something that there's no friction with the floor, I should say. Try to make something that bounces a lot. Okay. That's pretty bouncy. It looks like it might just bounce forever. We could wait, or we could just believe that maybe it will. Okay, so a few different things there. Something to explore and something that wasn't explained very well is, you know, what is damping then? And if I change damping, what happens? And we can see that changing damping will damp down that bounce. So here I'm just having damping at 0 and the friction at 0 and the restitution at 1, and that gives me sort of the most bounce, the best trampoline. All right. Let me shrink this down a notch. So now my next goal is to build out the walls here. So taking this same idea here, now I have another floor there. But this time I'm going to scale it differently. So if I'm going to build, let's say, the wall on my left, then that means that I don't want the wall to be very wide, right? I want the wall to be thin. So that means that the X component is thin, and now the Y component is tall, and the Z component is deep. And I'm going to position this at -5 on the X and 0 on the Y. And now I've put up a wall over here, right? So now I can bounce off of that wall instead of just clopping onto the this wall. Continuing on, we build a wall on the other side. All right, so now we have 2 walls and a floor.
I have a quick question. Why are
Yes.
we making those walls if we already have the box? What's the difference?
The difference is that I can attach grid shapes to these physical bodies. And the world box is a little more finicky. It's not something I should really use, in my opinion. Actually, not really sure. I should be able to turn it off, and I should be able to basically, throw this box out if I could make it go out the front.
Does it go away if you unenable the draw space?
Well, it's hard to say. No, I mean, drawing it's different than it being there. So, oh, that's because I put the world box on the wrong thing. Okay, this doesn't need to be here. There we go. So now I have to say world box on or off to the physics engine associated with the world. That's the one I'm using. I wasn't using that other one. That's why I got confused. All right, and then I could turn it on or off, right? So eventually I just want to turn it off. Kind of interesting what's happening here. I would expect this ball to launch out of the space soon. So I'm going to give it a little impetus to do that. So with any of these bodies, you can send them an impulse to move them in a certain direction. So if I wanted to move this toward us, I would say just give it an impulse toward us here with a force of 10. And so I'm going to send that to the ball. And there it goes. How do I get it back? The reset message will bring the ball back to us, right? And then I could give it a little bit more reasonable force and say, well, just come toward us more slowly. And now it's going to bounce toward us, and then it's going to fall off. Okay, so the goal though was to build a box that the ball will not fall out of. So we're going to kind of build a world around us that has physical properties, and then put the ball in that space, and then attach a light to the ball. So this impulse thing is nice. Since I'm here, I also would like to look at the idea of torque. So basically spin. So there's also a thing called a torque impulse, and we could spin the ball in a certain direction, right? So I could spin it on the x-axis. So I give that ball some spin, and if it had any friction, it would sort of bounce in a direction. Or I can spin the ball. Okay. Also, I notice if I start manipulating some of these objects in the physical space, the properties of this change. So live coding in this way is not particularly effective. All right, so we need to continue building out the walls, and eventually I'm gonna put grid shapes associated with these things as well. Let's just do it now. So I'm gonna have a jit.gl.gridshape on the draw space. And the only thing I have to specify here is what shape it is, because the shape of the physics object is just saying how does that physics object interact with other things, like what's the shape it uses for that. They don't have to be the same thing, actually. So I could make a sphere grid shape that's attached to a cube physical object, and that would work. It would just be dumb. Okay, so here's my cube. I don't really have to specify anything else about this because it will inherit a lot of objects, a lot of properties, sorry, from this physical body, namely the position and the scale and all that stuff. So this is our right wall, I think. So I do that, and now the right wall is there. And put this one here, and then put one on the floor. So for every one of these physical bodies, I'm going to have a grid shape that displays it. So I have to draw it as well as have the physical body. And again, it's nice to have a material for these. I'll just use the same material for all of this. There we go. Right, something like that. So now it's like that.
Quick question: is the physical body, the phys body, going into the grid shape? Like, did you?
It is binding to the grid shape is a better way to think of it, because there's actually nothing coming out of this object that we'll be able to see, I don't think.
Okay, I got you.
So internally, you know, under the hood, there's something happening here to pass information between the two. But much like the multiple object and a grid shape, and they can bind in the same way, this is the same sort of thing happening here.
Okay, I got you.
For the sake of it not looking terrible, I'll put a jit.gl.light in here in the draw space, and I'll make it a type point. There we go. So now there's a light kind of hanging right out around here. Makes our stuff look a little better. I could go in and select a material that looks, you know, more interesting to me. There we go. And you know, all this still works, obviously. Okay, so let's build out the rest of it. I'll build the back wall, and we'll run into a problem here pretty soon, and then I'll bring us to our next topic. So here's a cube, and I need to put this one 0, 0, -5, so it's in the back of the rectangle here. Whoops. And I need to scale that so that it is not very wide on the Z, right? So back this way it needs to be thin, and then this way and this way it needs to be tall. Yeah. There we go. So now it's back there, and I can just associate this thing with it. Hook the material to it. Okay, so now we've built the back wall. I'm gonna how they say it, take the roof off or whatever. Leave the roof off. All right, so now I can reset the ball, and now, you know, if it goes you know, back toward the back wall here, then it's no big deal. It'll bounce off the back wall, and now, oh, there it goes, off the front wall. So now we've got to build the front wall, right? And actually, in many ways, maybe I don't. Maybe I want this to be a little different. Maybe I'd like for this to be a longer haul. Maybe I'll do that in a second. But for now, let's just put a camera in there, and we've already got a camera, and move close to it. So now we're inside here, like this. So why am I doing that? Because I'm going to build this front wall, right? And if I build the front wall, we won't be able to see. So let's do that. So here is
Can you just like not associate a grid shape with it?
Yes, you could do that. But if I want to be inside there, maybe I want to turn around and like look behind me, and it'd be disconcerting to see that, you know, there's an invisible wall. So this one just gets positioned in front. So, and then we can associate this shape with it here. But let's not associate the shape with it yet, because I want to point something out. So I reset this, and then I go to grab the ball. What's going to happen? Right? It grabs the wall that's in front of me, which has no mass and doesn't respond to this. So I'm like, well, that sucks. So maybe if I just, you know, went closer to it. Nope, you're still grabbing the wall. Oh. And so at that point you say, well, I guess that means it just doesn't work. So I'll go to Unity. But you don't have to do that. Let's put this here. Let's associate a material with it. And then we'll just journey inside the box. There we go. This box is a little small for me. So let's change it. So basically I want to scale each of these to be longer toward me. So I'll make the the Z a little longer for all these. That one can just stay there. Maybe. And okay, that's a little better. I'm gonna move this one back to maybe. Does that work? Yeah. Okay, so now I've got this sort of long haul I can throw the ball in. And actually, curiously, that was kind of working. I'm surprised. Well, okay, problem solved. But if it did not work, so, you know, for whatever reason, I'm grabbing the wall, and it won't let me grab the ball, which I'm really surprised that's working. That's really great. Okay, how to make it stop. So what I could do is I could say, you know, there's not many things I want to grab in this space. I just want to grab this bouncing sphere. And so what I could do is I could make a filter class for this, right? So here I'm going to use the word filter class, and I'm going to use the word filter class on this body here at filter class ball. Okay, and then for my picker here, I'm going to filter out everything except ball. So now it should not grab a wall, it should just grab the ball. That's the theory. Right, so we can make it so that things don't interact necessarily. Filter class idea. All right, so last thing we wanted to do, right, is that right now the light is just kind of steady in there, but what I want to have maybe is a dark space that this ball becomes the light that's thrown around. So the question becomes, let me do this. Let's get rid of, this is all of this is the box, right? So I'm just gonna do one of those and bounding box here, and I'm not sure that made that very happy. Oh, I have to do the material inside here, it looks like. That's odd.
Dr. Thompson, does the picker need to be at filter class ball, or is it? I see at
No, because the filter class is what you belong to, right? I'm called book, right?
Uh-huh.
And then the filter is like, what things do you interact with? You're like, well, I interact with book, but not paper.
Okay.
Right. So filter class is the name of the thing, and then the filter is like, do I interact with that thing?
Okay.
If that makes sense.
Yeah.
So let me hook these things up again. Kind of interesting that doesn't work outside of there, but whatever. If I wanted to make this material load up correctly when we start the program, there's a little trick to that. So notice that this is called dirt.wall. So you would be tempted to say, well, there's probably a way to load in a material file like mat file. Right, so mat file, dirt wall. But if you expand that out a little bit, you see that it says JIT MTL. So it's important that if you're going to load bang in something like that you don't just say load bang dirt mat file dirt.wall, but rather that you say load bang dirt.wall.jit material. So just for the sake of doing it, we'll do a load bang here, and then mat file dirt.wall.jit material. Okay. So now in theory, when we open up the program, it'll load the correct material in. All right, so now that bounding box just exists there. And we wanted to get the position, oops, so this ball also doesn't have the correct material. Here it is. And let's make this one be, a rock bed. Marble? Rock bed. I won't change the color. All right, so now we have the same thing, and we can stop drawing this world now. So the physical world, and we want to be able to attach. I feel like something changed here. It did. It seems as though I lost something from this. Oh. So damping 0, 0 at friction 0. There. Yes. Okay, so now I want to attach a light to this. So how do we know the position of this ball at some rate, right? So we've already got the light in the space. There it is. And basically what I want to do is I want to say wherever you are, the light needs to be where you are. So let's take a look at the reference for this grid shape to find out if there's a way to get the state of the object, and there is. It's called getState. And if I send this, oh, it says filter is not a valid attribute. Filters. There we go. So now it doesn't pick the walls, just the ball. Okay. GetState here will get the state of this object, and out the right outlet will give me lots of different stuff. So I'll just print for now what's going to come out of here when I hit this once. So kapow, and then we get the state of this object, which is more than we need. But here's the scale, and here's the position, right? So this position is changing as this ball moves around. So what I need to do is just route out the word position and get these numbers. Or better yet, just get this whole message. So, and I need to do this getState thing at kind of a steady rate. So the best way for a steady rate here is just the draw message from the jit.world. So that sends out a bang at the frame rate. And we receive the draw here. And now we're getting this state a ridiculous amount of times. And we could do route position, which would strip off the word position. You know, so if it receives a list that says position, like it does here, it would strip off this word position and then give me the 3 coordinates. But I don't want it to strip off the word position because I basically want to say position those 3 coordinates to this object. So instead I'll use route pass. So route pass will only get the message position followed by the 3 coordinates. And I can just use that to move the light. So I'll hook this to the light now, and now the light is associated with that ball. And if I throw the ball around, the light moves with it. Right. And you could imagine, for example, making a game of 3D Pong would be pretty fun. There we go. It's exciting. I don't really like this material we have on this ball. I'm going to change that. Well, you can't really see it, I guess. Might need to put a different light in the space in addition to really be able to see it. Now, of course, we could change the type of light this is. It's going to look really bad, but we can try spotlight. So here we would have some sort of spotlight. You know, in this case, the spotlight's always pointing, this thing is always pointing in the same direction no matter how the ball is spinning. So a nice challenge might be, how would I make it so that the look at position here, or, you know, for the spotlight, changes when the ball spins. But for now, I'll just leave it as a point light. There we go. Okay. That's basically what I wanted to go over today. Basic physical space. Now, there are some things in here that... make another light. There are some things in here that are implied that we can do that we're not going to get to today, but you can look forward to. So one of those is, when I grab this thing, it seems to have a constraint on it, right? So that, it does things like it flips around when I'm holding. Maybe there's a way I could make a pendulum, for instance, by having some sort of steady thing in the world and then attaching something to it with a constraint, Maybe there's a way that every time this hits a surface that I can get a notification about it and I can trigger a sound when that happens, right? Might be a good idea. So those are the things we'll do in the coming days, are to look at how to start making more audio visual with this. So every time it hits a wall, for instance, I'd like to know, and I'd like to make a sound. Also, right now we're only dealing with one physical body in the space. And what if we want to have multiple of these? What if I want to make 60 of these and let them bounce all around? How would I do that?
JIT.gl multiple?
Right.
No.
Well, you would be able to draw multiples with JIT.gl.multiple, and you'd be able to have multiple physical objects with JIT.phys.multiple.
Oh, okay.
And we'll look at how to do that exactly. All right, so ask me a couple questions. It's just so clear.
Pretty clear.
Fairly clear. I think actually, making the Pong game is sort of an interesting thought. Widen out this hallway and make the walls so that they're not as tall, and you can move them up and down with a MIDI controller, let's say, and then just make a simple game like that, right? And see what happens.
I think it'd be more interesting if you try to make a multiplayer game where it's controlled by two different people in two different areas.
Sure. I mean, as many MIDI controllers as you have is good. Are you talking about like remotely?
Remotely.
Yeah, no problem, right? I mean, because, all right, so that's interesting. Because I used to work in a place where we used Max, actually, to make 3D worlds. And what was interesting about that is we had to project that world all across a spherical space. So the question is, what kind of graphics card do you have to drive, 8, 10 projectors? There's not one that does that. So instead, what we did was we had the world running on 8 to 10 computers, each with their own graphics card. And so obviously being able to transmit this sort of graphical space in high resolution and in stereo across a network is more challenging than just giving the data to each world that's pointing in a different direction. So there's a camera in each world pointing in a different direction, and all we did was just say, well, this object, right, there's a master computer that says where it is, and then we would just pass the positional data to each space to draw it, right? So if you were running 2 of these worlds, maybe each with a different camera view, and you just passed back and forth positional data, then it would be pretty easy to make that game. Although here you're dealing with a physical space, so that's kind of an interesting question. So I think you would actually have to pass the data to a singular computer for physical space and be able to do it. But yeah, sure, a multiplayer game. That'd be neat.
I have a question.
Mm-hmm.
So if you were to make a Pong game,
Yeah.
you'd probably want to constrain it so that the ball could not move forward or backward in space on the z-axis. Are you able to put those kind of constraints on the physics and say it can only move on the x and y-axis?
That's a great question and one I thought of this morning, and I don't know the answer.
Okay.
But yeah, I mean, to make a 2D game, right?
Well,
But it could be a 3D game that only moves in 2D space.
Yeah. Right.
Couldn't you just make walls that stop it from going there that are invisible to us?
I guess that'd work.
You would have a
That'd
slight bounce,
cause
right?
weird. Yeah,
Yeah.
it could cause weird issues if it.
I don't think I think that's a solution. I don't think that's the ideal solution. The ideal solution is like just don't go on the Z anymore. Just don't do that. And I don't know the answer to that question. I would be surprised if you couldn't do that, but I don't know how.
I have a question.
Yeah.
The JIT.mo object that we did like last week, I believe.
Hmm.
Could you put a physics engine on that and make like a dodging course? I don't know what it's called.
Let's see. So JIT.mo, this doesn't make anything but. I've already forgotten how to use these, but this doesn't make much of anything, right? We just need to have the JIT.mo. What is it called? Join. Right. So this would get our just sine wave motion, but what are we doing with that, right? So I think this had a dimensions.
All I'm saying is like, there's more objects to build besides just generic geometric shapes that would be physics, that I can have physics put on them.
That's right.
That's what I'm asking.
Yeah, I mean, so like a model, for instance, like jit.gl.model
The duck.
file. Is it duck.dae? Can't remember. This is on.
Well,
Drawspace.
I'm talking about like fluids. I'm going more of a fluids.
Fluids.
That's normally done with like a shader, like a liquid material.
Okay, let me wrap my head around what you're saying. So, before we had how did we do it? We had a mesh, right? That took the jit.mo stuff and used the jit.mo to determine the vertices of the mesh, right? So yeah, I mean that mesh could be something that has physical properties. You could make a model that has that as the collision mesh. If you used the jit.mo to provide a positional matrix for a multiple object, then you could have multiple grid shapes or whatever in the space, multiple ducks even. And then each of those could be associated with a physical body. So what I'm having a hard time wrapping my head around is, do you mean it has a collision detection for the mesh or for the multiple? Like each thing within it or the whole thing has a collision detection?
The whole thing.
Yeah, so like a mesh. But I don't think that would be very liquidy because it would be the mesh.
Well,
is
my brain went off on I saw the duck and I was thinking
ponds.
just ADHD moment for me.
I mean, I think what you're
Bathtub.
saying probably relates more to forces, right? So you could have a force in the space that moves things like wind or like water, right? So current is a force, so it pushes in a particular directional vector, right? So if I had wind blowing from left to right here, the ball would always be sort of leaning to the right and be pushed to the right by a force, and I can move that force within the space.
A cheat code for the game.
I don't know what that means.
No.
Are you able to have volumes, like if let's say you had water and you had the ball enter that volume, that could trigger things and have like a different state within that material or that
I know what
object
you
or,
mean. I'm not sure.
like change the
like-
color of the ball when it enters the space of a cube or something.
Yeah, so like the unity function, which is on enter or something like that, right?
Yeah.
I'm not sure. I don't know the answer. You can have like a concave or a convex hull, and it seems like if you had a concave hull, that maybe you would know if something's inside it. Not sure. I don't know the answer to that, but I don't see why you couldn't. But maybe it's just not built in. That's a good question. Many of the questions I had yesterday were thwarted by the fact that the Max database for looking up any questions that have ever been asked was down, was broken.
Wow.
And it said something scary like, what was it? Topology deleted.
Whoops.
I'm like, I'm glad I don't work at Cycling 74 right now. That sounds pretty bad. So I don't know if it's back up yet or not, but that would be a good place to ask such a question. Let's find out really quick, just for fun. By the way, I put a basic physics patch up on the Folio thing that basically does what we did here, maybe a little bit better. I don't remember at this point. But it's definitely more organized, I think. Let's see. Volume physics cycling 74. Well, let's find out. Oh, great. So it's back up. The world is saved. Because yesterday I was like, wow, I guess I rely a lot on this community because when it's gone, you're on your own. That's it. You want to figure it out? Good luck. All right. Well, that's all I have for today. You should be working on your final project and incorporating whatever it is you need to incorporate. And remember that it should be audio-visual. So I did a little something that maybe is useful to you. Let me close this. And I posted it on the Discord, but I think I just linked to the movie or something. And so what I had done, will I be able to find this? Unclear. So here's the result of what I did. So let me go to new share the sound now. Okay, open with QuickTime. So I just made like a quick AV thing that would look maybe something like what you might want to do, or maybe not. I don't hear anything. Oh, there it goes. So anyway, something like that. And
Did you get inspiration from Jared to have a non-black background?
maybe, I think it came right after that.
And it looks like Easter colors too.
Yeah.
I like because they're like soft colors, because normally they're like sharp, aggressive, like really bright, highly saturated colors with a black background, and this one is like more pastel.
Yeah, it looks yeah. So anyway,
Comfort colors.
comfort colors.
Are you just like moving through the different states? Like, is it just that, I guess, the like original, like centered image, and then you just like.
Yeah, so let me figure out where I put this, because I have no idea what I even called it.
That's something I'm kind of like, not struggling with, but like thinking about how I'm going to do it, like how to switch between states and making it seem seamless and not just like, oh, yep, here's another thing. I don't know if that makes sense.
Wow. Okay, so
Crossfade?
I think this is our jit.motion stuff, right? Oh my gosh, I'll never find it.
Tyler, are you saying the motion of the objects or the appearance of the new objects or new states?
The appearance of new states, because I got like the motion of the first state and like another state, but I'm like thinking about how I should move between it.
Can I show how I did it?
Yeah.
Yeah, please. Please do.
See if it might. I need to see if I can open this patch.
Let me change the sharing properties here. What I did to answer your question was I just had some parameters that I just opened up. And what I did was I used Super Collider to generate a routine that sent messages at
That's
a certain
cheating.
rate. No, it's not. Yeah, so I just sent over the messages. So the sound was made in Super Collider, right? And what it did was it just looked into a file and kind of played back certain parts. And when it did that, it sent over changes in data associated with that to the jitter program. So anywhere I had a parameter that I thought was interesting, I just opened it up for that. So every time Super Collider makes a new journey through the loop, it just sends that data over. And in that way, I make a connection automatically between the parameter state of Super Collider and the parameter state of Max. And it just kind of runs, and you can get good things out of that. Now, if I were to make a real piece like that, I would have to do that a few times, maybe change how that gets mapped here and there, and then edit it in a program meant for video editing.
Is there a way to see what file your pattern storage is using? I'll share it with you.
Yeah, it should be an
Like a
attribute of
attribute, yeah.
which file.
I'll figure it out in a second. I'm just gonna get rid of this video playing for a second.
Jared's computer always has that sound like it's about to take off.
Yeah, it's because I always have it switched to the NVIDIA card whenever I put in.
Jet engines taking off.
Well, it's like a Rizet tone. It's always constantly going up. Makes me feel a little tense.
Yeah, so the way that I
Paul
did
laughed at. Never mind.
I think I know what the problem is. I think the sphere size is too big. Anyway, so I just used a pattern and I just interpolated between them, right? So, what I have it set, the way I have it set up in here is like, so it goes pretty seamlessly, right? It's like it'll go all the way to 18, like, and look pretty okay as long as you don't have any states in there that are empty, right? So if you like assign it to a state that's not particularly, like if there's nothing in between them, it won't know what to interpolate between, so it'll just jump to it. And that's kind of something I've been trying to figure out how to deal with.
Well, you don't have to go between adjacent or juxtaposed states. You can go between two different states, like between 1 and 5, without going through 2, 3, and 4.
Okay, well, I haven't done that. I was just thinking about the way that I'm doing it is I have it actually go with a line object. So it has to, and I just have it store the state that I'm in and go to the place that it needs to go. But yeah, if you could probably make it, I don't know how you would make it work by.
As I recall, there's some command where you say these are the two states, and then you go between them with a 0 to 1 message, right? Like go between 0 and 1 between these two states. So
Yeah, but how
of-
are you going to go from 1 to 5 without going to 2, 3, and 4?
Right, by saying like this is the parameter state 1, this is the parameter state 5, go between those two, right? It doesn't matter what 2, 3, and 4 are. And you do that by going, so the value is like go between 1 and 5, and then 0 to 1 gets you there, right? So instead of doing 1 to 5 as a line, you would just do 0 to 1 as a line between 1 and 5. I am fairly
What
confident
Jared's
that
saying,
exists.
and no, there's another issue, but you can because if it's in, it's hard to not make it interpolate between all of them, because when it's in between 1 and 2, it should only consider 1 and 2. It's not interpolating between 5 also. So you need to figure out which range it's in between. And then, or that's what I thought, because I was running into this issue with Pulsar with the wavetable interpolation, because it's like, I think I see what you're saying though, because it'll say like which selection, but then you could determine which one it's closest to, and you could determine that it is, so many increments away from stage 2, but then you also need to know that it's still as closest to stage 1 also, so it's still reminiscent of stage 1.
I'm really not understanding the principle of going from 1 to 5 without going to 2, 3, and 4 first.
All right, here you go. I got it for you. So my state of state 1 is I have one number. It's 10.
Okay.
And then I have other numbers in 2, 3, and 4. And then I have parameter state 5, and the number is 20. And I say go between state 1 and state 5. Like, okay, between 10 and 20. So I give it the correct command that says between these two states, and then I draw a line from 0 to 1, and it should go from 10 to 20.
Okay, yeah, I'm understanding that, but how are you telling the pattern to do that? Because in my experience, you have to go from store 1 to store $1. You're telling it.
I think there's a different way to do it. I think you'll just have to look at all the different attributes, because I believe there is a way to go between two non-adjacent states.
Okay, that would be very helpful.
Yeah, I mean it's not something you'd have to figure out like a process. It's like there's a command that will do that. And I just can't remember off the top of my head what it is.
Okay.
But I'm pretty sure that exists.
Regardless, I thought this was a pretty good way to kind of go between states for jitter.
Yeah, and you'll notice that in your client objects window there, you can actually change how you get there, right? So it doesn't have to be a linear way. And you can exclude certain ones from it. So if you don't want them to interpolate, then you can do that.
Yeah, like have some of these are turned off because they ruin it if it doesn't.
Yes, this is similar to what I did. I mean, if you can imagine getting a single message from a different place that's running a routine or whatever, or some sort of timed process, maybe it's a DAW or something like that, then maybe it just sends out, go to this parameter. Or maybe it actually has the interpolation value between them, or something like that. For me, what I wanted was something that had some rhythm to it that made me happier than not rhythm.
I had like a bunch of really cool ones stored in here, and they're just not here now. So I guess I loaded the wrong pattern object. Oh well.
Maybe
Anyway.
so. Cool. Thanks. Sorry, I'm reading the chats now. Ah, my meager restitution. Okay, yeah. All right, with that, I'm going to stop the recording and